This video will describe how to analyze a multi-layer well using allocation factors. First, an introduction to multi-layer well analysis. A multi-layer well is a well that intersects multiple formations, combining their flows. The reasons for doing this typically are that one formation doesn't provide enough flow rate to make the well economically viable. Therefore, we combine or commingle flows of multiple formations. In the past, analyzing these would be done with an equivalent single-layer model. But sometimes, the reservoir dynamics are complicated enough that we can't adequately describe them using a one-layer equivalent model, and that's why we need to turn to multi-layer well analysis. We already have a multi-layer analytical model in Harmony. This presentation is not talking about that. The reason is, that model assumes that each layer has the same initial pressure. This assumption is not always appropriate. There is a way, however, of handling layers having different initial pressures, and it requires, in our current implementation, allocation factors from production logging tools. These are used to allocate rates from commingled production down to their respective layers. First, let's look at a single layer well as a reference. Typically, we will record the rate and wellhead pressure. We can then compute the sand face flowing pressure using a well bore, and the layer rate and sand face flowing pressures are provided to a reservoir model. History matching and forecasting can then be performed. In a multi-layer well, again, we record the rate and flowing pressure. But then we'll run a production logging tool, such as a spinner or a distributed temperature survey or DTS, in order to figure out the proportions of flow from each layer. So here's a diagram showing our total commingled rate and also the calculated allocated rates from each layer as determined by the production logging tool. Knowing that, we can take layer 1's rates and use that to calculate its flowing pressures. Those rates and pressures are then sent to a reservoir model specifically for layer 1. For layer 2, we use its rate to calculate its sand face flowing pressure. Those rates and pressures are then sent to a reservoir model specifically for layer 2. So the overview is, for each layer, we can take commingled rates, enter some allocation factors, and determine what the rates and therefore the pressures are for each layer. We can then history match and forecast that layer, and do that for as many layers as we have in our well. Taking all the forecasts together and adding them results in a commingled forecast at the well level.